Thank you, Vishnu.
Let's talk to. So here you go. As I mentioned in the first board, Mr. Rahul has to solve problem at two levels. One, when this packet reaches to the switch, how this switch is going to forward this only to yellow host and not to the blue host. As simple as that. And the second problem is at the layer 3 also, right? So I want to showcase you two different traffic flows which you need to understand, right? One is, suppose I have a source here which is a white color host, and this source as a video song, right? And this video song is interested by these yellow hosts which are inside the gray network, right? And I have put a router here. Why router? Because I have two different networks. This is network number one, this is network number two. And of course, routers connects different networks, as simple as that, right? So it might be the case that this source is sending the video stream to the router, and router knows that gray network actually asked for it. How gray network is going to inform to this router, it is totally different thing which we are going to read. But now let's suppose router knows that this stream, this video stream which I am denoting from this red color, right? Gray network has shown interest in it. So what this router is going to do, router is going to put this stream on this switch, as simple as that. Now this switch understand that Mr. Router is sending. It means that this stream is coming from some different network, right? So we need to consider this scenario, right? When we are getting the stream from totally different network, this gray network is the one network, and I'm getting a stream from a source which is located into totally different network, right? The second thing, it might be the case that the source itself is present in the local network. It can be the case. Why can't it be done, right? It can happen this way. Means this computer is my source, and this also has a video song in which these two hosts are interested, the yellow host, right? But the interesting piece is now my source is not in some other network, it is directly connected to me, right? If that is the case, the second stream which I am talking about is simple, right? It will be coming from here to directly switch, right? So try to understand the difference between these two streams. One stream is coming from different network, and this stream is coming from the same network, right? Generally, all you know about it that if this source is sending a multicast packet, or basically if this source is sending a packet or the video stream, if it is going on this wire, we need to put source MAC address and destination MAC address. It is as simple as that, right? If this is having source MAC and destination MAC, if this switch is not going to find the destination MAC address in its CAM table, it is going to flood it. It will send it here, it will send it here, it will send it here, right? So we need to understand how, right? Today class is totally dedicated to the fact that your source is also inside the same network, as simple as that. If that is the case, then how it is going to happen, how the switch will know that there are two different hosts which are interested in this stream, in this video stream, and this host is not interested at all, right? If that is the case, we are talking about two different things. How multicast happen inside a single network, and how multicast happens when we are getting the stream from totally different networks. So today class is totally based on what is going to happen if we are talking about this network only. And if that is the case, I am removing this router from here so that I can put my total concentration right here. There is no router now, but you need to understand that there could be another use case also in which a router is connected and the stream is coming from top. But now I have totally eliminated that use case. Now I'm talking about that my source is also inside the same network, and maybe The IP address of this source is 192.168.10.100 because it is a part of this network. And maybe the MAC address is C:C:C. In this network, we have three more hosts. One is this blue one, and two hosts are yellow. This source is having a video stream, and in this video stream, these two hosts are interested. How they are interested? How come on earth they know about that this source is going to send this video stream and I need to show the interest? We will be talking about it. But for now, just presume that this host A and host B are interested and this host is not interested at all. In what? In this video stream. Host A IP address is 10.10 and I can say this is the receiver because this is interested in the stream. And this host multicast address is A.A.A. Similarly, the host B is right here. The IP address is 10.20. The MAC address is this one. But here is my thing. Here is the important thing. If this guy wants to send an IP packet, and suppose what is this video stream? Video stream is just nothing but a data, right? And it's a lot and lot of data. And I'm talking about a particular piece of data. So what is going to happen? We will take this data, and at the end of the day, this data should reach to host A and host B. So what we are going to do? We are going to put it inside an IP packet. It is as good as putting this data inside an envelope. And then we are going to write source IP address and destination IP address. What should be the source IP address? Source IP address is going to be 10.100 because 10.100 is my whole source, right? Or the sender. What should be the destination IP address? And it is very, very interesting. Because destination IP address cannot be 10.10 and destination address cannot be 10.20. And the reason is because both of them are interested. But the IP packet can take only one destination address. You cannot put more than one address here. And suppose if you can, suppose the destination IP field can have two different IP address. It can carry two different IP address. That is going to be fine if you want to send this packet to two different IP addresses. But it might be the case that this network contains 100 of hosts, right? And out of 100 of hosts, 50 hosts are interested in this data. If that is the case, you cannot write 50 destination IP addresses, right? And that is where you need one address that can represent both of these hosts. I need something which can represent host A as well as host B. Very, very interesting, right? Host A is going to have the address, and host B is already having the address. Host A address is 10.10, host B is having 10.20. There is no doubt about it. This is the IP addresses they have. But now I am not sending two streams to them. I am sending one IP packet. One IP packet is going to contain only one destination IP. And I am saying whoever is interested in this data stream, they are going to have this new magical IP address, which is x dot x dot x.x, and by the way, this is the IP address. But now multiple hosts can have this IP address, believe me. But you can argue with me, Mr. Vishnu, I have never ever configured one address to multiple hosts in my entire life. And I agree with you because it is going to happen automatically. How? I will let you know, but you should understand this fact that this data stream is now going towards two computers, not the one. We need an IP address, right? And I'm saying this is my magical IP address x.x.x.x because this x.x.x.x is not representing one host. It is not representing maybe two hosts, maybe three hosts. It represents a group of hosts. Here, the group has only two hosts, which is 10.10 and 10.20. Means this address is representing right now a group, not a particular address or not a particular host. And that is why we are calling these addresses, these magical addresses, as group address, not the individual address, guys. As simple as that, right? So we all agree that this source is going to create this packet and I will be sending this packet to x.x.x. It means that I need to learn a new, something new magical IP address. And this IP address range for this, whatever I'm calling the magical, is known as IP multicast address range. And I will be talking about it. What is this IP multicast address? And we will be learning something new today, right? So at IP level, I am good because see, if you are talking inside it, inside the same network also, you need IP address for that, right? We have talked about it in the switching course, right? Although, if you go at the nitty-gritties, this switch does not need an IP address to forward the frame, right? It just needs the MAC address. But still, you should know where you are sending the message, right? You should know the destination IP address, right? What is going to happen at the layer 2 level? If you have the destination IP address, if you know where are you sending the packet, you need to have the MAC address also, right? Why? Because if you want to send this message over this wire, this is my Ethernet wire, and Ethernet wire can carry data only if you put source MAC and destination MAC at the front of this, right? Because we all know switch doesn't care about IP addresses. They do not understand IP addresses, right? If you want to send this IP packet, which is having this video data over this wire, you need to have source MAC and destination MAC. Believe me, guys, whatever the concept we have built while learning routing, switching, whatever, right? Those concepts are never going to change. Everything will be like that, right? We are just improving our network. That is it. We are just improving our network. So source MAC is going to be what? CCC, right? Because this is the host which is sending this message. What should be the destination MAC? And here again, very, very interesting thing. What had happened when we did the unicast? You all know what we did. We see where we are sending the message, destination IP address, right? We know the destination IP address, but we do not know the MAC address. So what we do? We do ARP, we do address resolution protocol. Suppose this guy wants to send a packet to this blue host. This guy knows the IP address of blue host, but it doesn't know the MAC address of blue host. So what is going to do? It is going to send the ARP message, which is very, very important. And when it gets the ARP reply, it knows the MAC address of this blue host. This is what we have discussed in switching section also, the switching course, right? But now here, we are not talking about one address, right? Because this magical address x.x.x.x is not representing one host, so we cannot send the ARP and expect that it is going to return me one address. Very, very interesting, right? It means that if I know the destination multicast address, which is x.x.x.x, which is a magical address, I need to know what is the MAC address. If the MAC address is not there, the destination MAC is not there, I cannot put this packet right here, right? But I also know the fact that this x.x.x.x is not representing one host, it is representing the group of hosts, right? And if all those group of hosts will replying with their MAC address, then again I am having the same problem. I can put only one destination MAC address, not multiple. I cannot do ARP here. It means I need to think something. I need to learn another range of addresses, which is MAC address, which is multicast MAC addresses, right? So believe me, if you know the IP address, if you know the IP multicast address, you can calculate on your own the MAC multicast address, because you all know MAC is absolutely necessary here. This source cannot send this packet unless it put the destination MAC address. But destination MAC address is slightly special in this case. Why? Because we cannot do R. Why we cannot do R? Because it is not going to be one host, because it is a group of hosts. It can have 50, 60, 80 hosts, right? I need to have one MAC address, which this switch also understand. Very, very interesting. Suppose how it got converted, I'm not talking about it, but I can tell you that there is a way that if you know the destination IP address, destination multicast IP address, then you can calculate the destination multicast MAC address, and suppose that is y.y.y. If that is the case, my packet is completed, packet is right here, right? So can I say that these two hosts have a common IP address, which is x.x.x.x, and common MAC address, which is y.y.y.y. It means that this host is listening at x.x.x.x at this IP address, and this host is also listening at y.y.y MAC address. This host is also listening at x.x.x.x IP address and y.y.y MAC address. But these two addresses are special because you can see that you can have the same IP address across two different hosts. If that is the case, very, very interesting. Try to think, if this message comes here, what switch is going to see? Switch will see that it needs to go to y.y.y because switch doesn't understand anything apart from the MAC address. It will say this packet wants to go to y.y.y.y. It is going to check its CAM table, and CAM table is not going to have this magical address, right? Because it is having only the unicast addresses. And if CAM table is not going to have this address, what switch is going to do? Switch will see, oh, very, very interesting address. I do not have this address in my CAM table. I will presume it as unknown unicast. Guys, remember the switching section. If a switch receives a message or a frame, right, with an address which is not present in its CAM table, it is going to flood it. Means what is going to happen? This stream, whatever the source is sending, it will be received here, it will be going here, here, and here. And this is what exactly Mr. Rahul doesn't want. Rahul do not want to send this stream to this blue guy. Why? Because it might be a contractor, or maybe we have 100 people here. Out of 100, only 2 are interested. This stream is going to those 98 people also, because switch treats unknown unicast as broadcast. It is going to flood it, right? It means that I need to understand one more thing. Definitely, I need to understand layer 3 magical address, which is x.x.x. I need to understand layer 2 MAC address, which is y.y.y. And I need to understand how switch is going to behave in this case of a special MAC address. Believe me, when we read about it, this host is going to inform the switch that I am interested in y.y.y because switch understand only MAC address. The second yellow host is also going to say, I am interested in y.y.y. It is saying I am listening at y.y.y MAC address. And if this is the case, suppose this is the 0/4 interface, this is the 0/3 interface, switch is going to create another table in which it is going to write that MAC address y.y.y.y should be forwarded over 0/3 interface and 0/4 interface. Very, very interesting entry. We don't see such entries in the unicast CAM table, of course, right? Because we used to see that switch does either the unicast or the flood or the broadcast, right? But here, if a packet comes with the address y.y.y.y, I am seeing an important table switch is creating now. If it is getting this magical address y.y.y, switch is carrying it, right? Switch see, this is y.y.y, this is magical, right? And if it is magical, it can go over multiple interfaces. It can go over 0/3 and 0/4. So eventually switch is going to forward this packet here as well as here and not here. But We need to make switch aware of these addressing, right? And believe me, there are protocols for that, and we are going to study that. I am just creating an overall picture. What is going to happen? Very, very interesting, right? But before that, from this board, the takeaway should be I need to understand something about layer 3 IP addresses, which are the multicast, layer 2 multicast addresses also. And if that is the case, let's move to the new.